bottom ones, we have to be really careful because our formula was given to us in terms of radians, and this one is given to us as degrees. So on here, this was given to us as radians, pi over 2 is radians. What is its equivalent in degrees? 90. So when we're doing degrees, use 90. I just didn't want to write the formula twice because that would have been way too much. Holy cow. So when we're writing it as a cofunction of the complementary, we're going to take our secant is going to turn into cosecant. And then since this is degrees, we're going to do 90 degrees minus our theta that we have here, our 15 degrees, 20 minutes. So do that simplification. What is 90 degrees minus 15 degrees, 20 minutes? So this is going to become the cosecant of 74 degrees. How many minutes? 40 minutes. Same thing with tangent. Over here, we're going to take our tangent and we're going to turn this into our complementary cofunction. So our cofunction is cotangent. And the way we get our complementary angle, again, this one's in degrees. So we're going to do our 90 degrees minus 27 degrees, 35 minutes. Bit of minutes since we did some degrees and minutes subtractions. So they come back every now and then. So we're going to have our cotangent of what is 90 degrees minus 27 degrees and 35 minutes. $62 and 25 minutes. So these are all well and good, finding our complementary angles and cofunctions, but they don't help us evaluate these super hard. Like, I can't do sine of 3 pi over 8 any better than I can do cosine of pi over 8. I can't evaluate secant of 15 degrees 20 minutes any better than cosecant of 74 degrees 40 minutes. Like, great, but it's not super helpful. Yes, dear. Yeah, so we do so simplifying these angles, we'll take the 90 degrees and think of it like 27 degrees and then some. So we know for sure 90 minus 27 we can do, and that's going to be 63. But I really need to do the minutes too, so it's going to be 63. Oops. Yeah. 62 degrees and 60 minutes so that I can like carry it over and subtract the 35. That's where we got the 25 from. Okay. Yeah, it's just been a hot minute since we did that. So what we're going to start doing is we're going to start trying to evaluate these kinds of angles. And the way we're going to do that is by breaking things into pieces. So we're going to start by looking at something like this, where we're given operations on functions and we're asked to find exact values. This is not using our complementary cofunctions. This is evaluate. So I want us to think about the cosine of pi over 4 plus the cosine of pi over 6. And this is when it is really helpful to have our unit circle in here. Because what is the cosine of pi over 4? Square root of 2 over 2. What is the cosine of pi over 6? Square root of 3 over 2. Then we're going to add those together. If we are adding fractions, can I add those radicals together, like under the radical sign?
Yeah. No.
No. If we were multiplying them, we could do that, but not adding. Square root of 2 and square root of 3 can't combine together, but I can put them in one fraction. This is our answer for this one. That is the exact value of the cosine of pi over 4 plus the cosine of pi over 6. It's the square root of 2 plus the square root of 3 all over 2. Which does not look great, but it's a thing. How about the tangent of 60? What's tangent of 60? If you need to, you can also come in here and do your sine of 60 over the cosine of 60. Which, if you do it that way, you get our square root of 3 over 2 over 1/2, which gives us a value of the square root of 3. So you don't have to take this middle route to do it, but that is what we did to get the tangent of 60 being the square root of 3. Do the same thing for the tangent of 225. That one's a little harder. It's not in the first quadrant. It's going to take us a second to get around the circle there. And again, if it helps, your sine of 225 over the cosine of 225. What is the sine of 225? The tangent's going to be just 1, yeah. Because my sine, that's negative square root of 2 over 2. And my cosine is negative square root of 2 over 2. So tangent of 60 plus tangent of 225 is the square root of 3 plus 1. Can we simplify that at all? Nope. That's our answer. Square root of 3 plus 1. Because what we're going to be doing is we're going to be looking at different kinds of equations and trying to do this with a couple of different angles. We're going to be taking and evaluating functions at these pieces because we know these angles. We knew these. We could pull these from our unit circles so we could use them to do operations. So what we're going to be looking at is when we're asked to evaluate things like cosine of pi over 5 or tangent of 75, those kind of things. And we're going to be using pieces we know to find pieces we don't. And so I'm about to put up another wall of formulas. These are the formulas we're going to be living in for the next 3 days. Okay? So, no joke, wall of formulas. Yes. You're going to want to write it all down. These are the addition and subtraction formulas. This is what we're going to be working with for the next 3 days. And this is what 90% of homework 7-3 is over. Oh. Stop with the whistling, because I'm not a dog. I know, I'm horrifyingly cruel. Because what this does is this takes angles and breaks them up into pieces that we know. And we're going to use this to take angles we don't know and break them up into pieces we do know. So I'm going to give you a bunch of time to write all these down because this is what we're going to be working with. What's up?
So your mom's sending out cookies to us?
I got 2 buckets of cookies over there.
For real? So I can get some?
You gotta try the challenge problem.
What's the challenge?
What's the challenge? How'd you push it?
Literally board that says challenge problem.
I can't see it.
Well, I know, it's almost like you have time to work. Dude, write the formulas down because I'm not gonna wait for you when you think about that.
Hey, first.
But yes, my mom is sending in for real cookies because that is a for real problem with a for real situation.
What does that say in the parentheses?
Biological means I'm not adopted.
Oh,
She birthed me, and her 18th birthday's this week.
Her 18th birthday is this week.
Mm-hmm.
Your mom's.
My mother.
18?
18th birthday.
You mean 81?
She's born out of 80.
You sure you didn't get the numbers confused?
I did not get the numbers confused.
Take a picture.
So she's 72.
Hush your face. Write down the formulas.
I mean, if you're like 40 something, like
Yeah, she's like
Not 40 something, but almost 40. Chill.
She's not 40 yet.
No, I'm not 40 yet.
She heard you.
I graduated high school 20 years ago.
I think we're 50.
That's crazy.
Ow.
That's crazy.
Full 40.
Ow.
I
That
don't
would
think you
hurt a
should
little
give her
bit.
Oh, no, not like that. No, I'm not trying to make
You shouldn't give him the cookies.
Wait. Is it like this week?
This week.
Oh,
Sit down
read the
and write down the
problem.
formulas. My mom will not be on the test. This will. Write down the formulas.
I wrote it down.
Good. But she is literally the reason why I make the challenge problem board because she's my favorite math problem.
What day is her birthday? You can't tell us.
I'm not telling you. There is enough information up there for you to figure it out.
What is her?
Her full birthday.
Oh.
Can we yell it out loud if we find it?
No, if you write on a little slip of paper, you get extra credit.
We get extra.
Oh my god. The box that has the papers with the question mark next to the challenge board that has the rules that say if you write it on the paper, you get extra credit.
The extra credit goes like what?
Towards your homework assignments.
Oh.
It goes towards homework.
Is that her birthday?
I'm not gonna tell you. Write out the challenge problem. You get one submission a week.
Can you tell me?
Read the freaking rules.
Because if it's on a leap year, it's the 29th.
Hey, bring me one, bro.
What's the extra? Oh.
Yellow box. It is bright.
You want one?
Bright yellow right there.
Yeah. I'm about to follow around this problem.
Yeah, photo math story problems.
Where do we turn it in?
Where do you turn anything in?
Shit, my bad.
Dude.
Yeah,
I swear you live in a cave sometimes. All right. So let's work with these a little bit. And why the heck we have these gigantic formulas for some addition and subtraction. Because our first one that we're going to be asked is, what is the sign of 15? And we are expected to find the exact value. But 15 is not on the unit circle. We don't know 15. I don't know the sign of 15 off the top of my head. However, we're going to write 15 in a different kind of way. Because 15, we could rewrite that as 45 minus 30. That means the same thing, right? Those two pieces mean the same thing. So I could rewrite the sign of 15 as the sign of 45 minus 30. And now there's a lot of different ways we could write that. I could do 46 and 31. I could do 50 and 25. Like there's a lot of 50 and 35. There's a lot of different ways I can do it. The reason I picked these ones is I know 45 and I know 30. Those are two pieces of the unit circle. We can do those. So if we use that formula we wrote down for sign when it had a minus sign. So if we look back at our formulas, we're going to be looking at this one right here. Sign of two things that are being subtracted. So we're going to take the sign of the first piece times the cosine of the second, and we're going to subtract it from the flip-flop. So when we use that formula, this is going to become the sine of 45. Just turn it in at the end, dude. We're doing stuff. Times the cosine of 30 and then we're going to subtract the sine of 30 times the cosine of 45. Breathe, chill. So we're taking a number we don't know and splitting it into two numbers that we do so that we can find each of these values individually. Because what is sine of 45 degrees? Think through unit circle. What is the sine of 45? Square root of 2 over 2.
We don't have to explain, right?
Doing this.
No.
I'm not listening to you at all right now unless it's about sine and cosine.
Can I get my cookie? After class?
Literally, I just said, unless it's about sine and cosine,
Oh, okay. That's yeah.
I ain't talking about it. All right, so then let's find our cosine of 30. What is the cosine of 30? Square root of 3 over 2. What is the sine of 30? One half. And what is the cosine of 45? Square root of 2 over 2. So remember how we did like a whole bunch of unit circle quizzes so that we could pull stuff up? I was not joking when I said we are going to continue to use it all year because that's where we're getting our answers for this, are from those unit circles. So we have all these pieces. Now we're going to evaluate with it. These two pieces are being multiplied together, and these two pieces are being multiplied together. So square root of 2 over 2 times square root of 3 over 2. When we're multiplying radicals, can we multiply the pieces under the radical?
Yeah.
Yes. So it's going to be the square root of 6 over 4. Thank you. Multiplying fractions, multiply across. Our other fraction, 1 times square root of 2, gives us just the square root of 2 over 4. Can I subtract the square root of 2 from square root of 6 and simplify it at all? No, they're both gross decimals, and I can't use addition and subtraction to combine them together. I can only combine my radicals when we multiply. So this is the exact value of the sine of 15. Is the square root of 6 minus the square root of 2 all divided by 4. That is the exact value. Okay, so it's all about breaking them into pieces so that we can evaluate them. Let's do one more. So I don't want to just practice it once. I want to do it twice before we get to the end of the day. Let's do one more today. And we have the cosine of 7 pi over 12. So we're into radians again. And so what we need to do is we need to break up 7 pi over 12 into things that we have on the unit circle. I know we do not have any fractions with a 12 denominator on the unit circle. So we need something that's going to be able to simplify. What is a way I can break up 7 pi over 12 into a sum that's going to have something that's going to simplify? What are some things that add up to make 7? 5 and 2. Will 5 and 2 make our numbers simplify into things that are on the unit circle?
3 and 4.
So finishing my thought, we'll think about that one next. So if I do 5 over 12, is that something on the unit circle? No. So 5 and 2 does add up to 7, but it doesn't help us. So if we think about 3 and 4, if I put 3 pi over 12, does that simplify
Yes.
into something on the unit circle? Yeah. Because we can make 3 pi and 4 pi. That adds up to be 7 pi over 12. These also then simplify to be pi over 4, which is something we know, and pi over 3, which is also something we know. So we got to break it into pieces we know. 5 and 2 does technically work to split up 7 pi over 12. It just doesn't help. Same thing with 6 and 1. Great, but 1/12 I don't know what to do with. So we got to break it up into things we know. So we're going to take this and make this be the cosine of pi over 4 plus pi over 3. That 3 is trash. Holy cow. And so we're going to use our formula. And cosines is a little bit different. So we're going to have cosine of pi over 4 times the cosine of pi over 3. The cosines always go together. And then they use the opposite sign. So we're going to subtract the sines of both of them. Sine of pi over 4 and sine of pi over 3. What is the cosine of pi over 4? It is in fact square root of 2 over 2. What is the cosine of pi over 3? That's a 3. It's a trash 3, but it's a 3. 1/2. What is the sine of pi over 4? Square root of 2 over 2. And the sine of pi over 3? Square root of 3 over 2. So we have a lot of really similar pieces here. We're going to multiply together. Square root of 2 over 4 minus square root of 6 over 4. And I can't really simplify other than to put them as one fraction. Okay? So we're going to be doing a lot working with these sum and difference formulas. Okay, so that's what we're gonna be working with in 7.3 is with these formulas most of the way. I'm gonna put up the last page.
Can we come back real quick?
Yep. I will not tell you until I post the answer because that is the same question for all 7 or all 6 of my classes. It's not just for y'all, and it'll be up all week long. So you have time.